Good morning to my professor, Mr. Bhaskar Sen Gupta, and dear viewers. Firstly, wishing you a very happy new year 2021. So, this is Pinnaka Venkat Laxman Kumar with registration number 20BCE0829. So, I am from the slot C1 plus TC1, and here I am going to take the topic as today's agenda is based on carbon nanotube, so which is a nano material. So let us start our discussion today. So carbon nanotubes. So firstly we need to know what do you mean by carbon nanotubes. Carbon nanotubes are a molecular scale tubes like structure of graphitic carbon with outstanding properties. So they are among the stiffest and strongest fibers researched still date, with remarkable electronic properties and applications. My dear friends, we are going to study the carbon nanotubes introduction part. So the carbon nanotubes are discovered in the year 1991 by Lijima, and it is a unique material properties. It has a unique material properties. So they are nearly one-dimensional structure, as well as they are broadly divided into two types, which are single-walled carbon nanotubes and multi-walled carbon nanotubes. Firstly, we need to know the exact definition of a carbon nanotube. So what do you mean by carbon nanotube? So what do you mean by carbon nanotube? So we can say that carbon nanotubes are nothing but rolled up graphene sheets in chair structure or zigzag structure and chiral structures. So carbon nanotubes composed of interlocking carbon atoms are 100 times thinner than an average human hair, but can be 200 times stronger than the steel. So carbon nanotubes are hexagonally shaped arrangements of carbon atoms that has been rolled into tubes. And so far we have seen what do you mean by carbon nanotube and how many types of carbon nanotubes, or carbon nanotubes is divided broadly into two types. So entire thing we have discussed till now. And coming to the structure of the carbon nanotubes, the carbon nanotubes possess at least two layers, often many more, and ranged in outermost diameter from about 3 nanometers to 30 nanometers. The bonding in carbon nanotubes is sp2 hybridization, with each carbon atom joined to 3 neighboring as in graphite. So the tubes can therefore be considered as rolled up graphene sheets. Graphene is an individual graphite layer. There are three distinct ways in which graphene sheet can be rolled into a tube. So these following figures represents us the figure A, which represents the armchair carbon nanotube. This is the structure of it. And coming to the figure B, it represents the structure of carbon nanotubes of the zigzag shape. And coming to the structure C, it represents the chiral structure of the carbon nanotube. So these, what are the figure below at the bottom of the slide, represents the microscopic structures of armchair, zigzag, as well as chiral carbon nanotubes. So here whatever the ordered pairs like 5, 0, 4, 2, 4, 4 are nothing but the indices of the carbon nanomaterials. So you will be having doubt like what do you mean by carbon nanomaterials, refractive indexes, or the ordered pairs. Okay, so the ordered pairs are nothing but we'll see in detail. So by you people may have doubt that what exactly these ordered pairs means it is different from the mathematical order pairs, or it is related to some other thing. So we are going to discuss about it here. The armchair structure and zigzag structure has a high degree of symmetry. The term armchair and zigzag refer to the arrangement of hexagons around the circumference. The chiral term means that it can exist in two more related forms. The internal arrangements of atom in the structure of a nanotube is as follows in figure. So the structure is specified by a vector which defines how the graphene sheet is rolled up. The carbon nanotubes can be produced with various values of n comma m. So by this we can understand that n comma m represents the carbon nanotubes various values. Okay. The whatever the n comma m ordered pairs are there, they will be vary with the different types of the carbon nanomaterials. Like if you take theta is equal to 30 degrees, which means we will get the armchair nanomaterial, so which has C60, means usually in chemistry we call C60 as a Buckminster fluorines. So here n comma n for this type of structure is 5 comma 5. And coming to the zigzag shape, theta is equal to 0. Here in this case, C70, the carbon atoms are totally 70. So the ordered pairs of m comma n is equal to 9 comma 0. So here it is. So coming to this part, the chiral part, here the angle theta lies between 0 to 30 degrees and the total number of carbons are 80. So we can say it as C80, which in the sense the C80 can be also known as the rugby component structure. So m comma n, the indices has said that 10 comma 5. Okay, so these tiny straw-like cylinders of pure carbon has used like electrical properties. They have already been used to make tiny transistor, which means like we'll say the microchip transistor. I think you got my point. And one-dimensional copper wire. So this is the way how the graphene sheet is rolled up to prepare the carbon nanotube. Yeah, this is the microscopic structure of different types of the carbon nanomaterials and their respective refractive indices. Sorry, I mean that it is indices. And coming to this part here, it is 10 comma 0, 4 comma 3, 6 comma 6 for chiral, 10 comma 10 for armchair, etc. So this following microscopic structure of the carbon nanotubes represents with its composition of its indices. Here you can see. So the red component is zigzag, here the green component is chiral, and here the whatever the blue component is there is armchair. And finally, many people has doubt that which type of structure will call as zigzag, which type of structure will call as armchair, and which type of structure will call as chiral carbon nanotubes. So we can say that if m is equal to 0, the nanotubes are called as zigzag one. If n is equal to m, the nanotubes are called as armchair. Otherwise, they are called as chiral carbon nanotubes. So this is a way how we broadly divide these armchair, zigzag, chiral carbon nanotubes based on their indices values. So the upper view of folded sheets. So finally I'm going to discuss the upper view of this folded sheets. The upper view of this folded sheets for armchair is this way. And coming to the zigzag, the upper view of the folded carbon nanomaterial is this way. And similarly for the chiral one is this way. So as a startingly specifically mentioned the types, it is broadly divided into two, the single walled and multiple walled. So they can be metallic depending upon the geometry. So coming to single wall, most single wall nanotubes have a diameter close to 1 nanometer with a tube length that can be many millions of times longer. The structure of SWNTs can be conceptualized by wrapping a one-atom thick thin layer of a graphite called graphene into a seamless cylinder. So how to get, people have get some doubt like how to get SWCNT. So this is the way I said the rolling of graphene, so which uses the carbon nano materials. So coming to the multi-wall nanotubes consists of a multi-rolled layer of graphene. So as you see here, there is what you people may get what is the difference between multi-wall and single-wall carbon nanotubes. So what happened in this case for the single wall nanotube is you will get the single layers for the nanotube, single layers only, as you can see in this figure. While coming to the multi-wall, you can see the multiple walls over here. So like this one is a layer 1, means wall 1, this is a wall 2, and this is a wall 3. So we can say there's a multiple wall C and D. I think we get the clarity about this thing. And finally, comparison between single walled and multi-walled. Single walled carbon nanotubes exhibit electric properties that are not shared by multi-walled carbon nanotubes. As I said, I want to say you people that the main comparison between single walled and multi-walled carbon nanotubes are there will be a lots of difference in the electric properties. So that should be noted off between the comparison between the two things. So, and coming to SWNTs is useful for the development of the first intramolecular field effect transistor FET. I think you people are more available, has some awareness in the semiconductors field. So, in the semiconductor, while studying the chapter semiconductor devices, you will people get learn. I think you people may learn about MOS FET. Okay, so in that thing which is used is this single wall nanotubes. Yeah, so finally with this I want to end up this session, and I hope so whatever the concept I was explained to you people is I think you people have understand it pretty well. So yeah, thank you.